Ever wonder if AI models truly understand the world, or if they're just pattern-matching machines? Today, we're unpacking a groundbreaking study that reveals how even the most advanced AI systems struggle to grasp the fundamental rules of reality. Let's dive into the science behind why these models often mimic intelligence without understanding it. Here's the setup. Researchers trained a state-of-the-art AI on data about planetary motion, like a chatbot studying an astronomy textbook. Then they asked it to predict force vectors, the mathematical backbone of Newton's laws of gravity. If the model truly understood physics, it should have generated the inverse square law, F equals gm1m2/r2. But instead it spat out chaotic arbitrary formulas like F proportional to sin r minus 0.24/r plus m. It's like asking a chef to make a souffle and getting a bowl of alphabet soup. Why did this happen? Newton's laws are deterministic. Given a planet's position and velocity, there's only one correct next step. But the AI wasn't learning physics. It was playing a game of pattern matching. Think of it like a student who memorizes math problems but can't explain the theory. When asked to predict an unfamiliar orbit, it panicked. It might guess the same answer for wildly different scenarios or flip-flop between similar ones. The team didn't stop there. They tested the model on other tasks, like the board game Othello. The AI could generate legal moves, but it didn't use the game's rules to guide decisions. Instead, it relied on shortcuts, grouping board states that led to the same next move. It's like solving a maze by memorizing the exit, not the layout. So what's the takeaway? AI isn't thinking like humans. It's a pattern matcher, not a physicist. But here's the twist: this isn't a flaw. It's a window into how machines learn. By studying these gaps, scientists can build better AI that truly understands the world, not just mimics it. The study introduces a clever tool called an inductive bias probe, a way to test whether models grasp underlying rules or just fake it. By creating synthetic datasets, like mini video games with known rules, researchers can see if AI predictions align with the logic. The better a model does, the closer it gets to real understanding. Let's break this down. Inductive bias refers to the assumptions models use to generalize from data. A strong inductive bias, like human common sense, helps systems infer rules. But current AI often picks up task-specific tricks instead. For example, a model trained on weather data might spot trends, but not grasp fluid dynamics. It's like learning to ride a bike by memorizing every turn on a specific route, but failing to navigate a new street. The researchers also compared models like transformers and LSTMs. Transformers, used in chatbots, excelled at distinguishing subtle state differences, like a chess master spotting tactical nuances. LSTMs, while effective for sequences, relied on surface-level patterns. Yet even transformers aren't magic. They're great at trend spotting, but lack true causal understanding. So next time you see an AI predict the future, remember, it's not thinking like a human. It's math plus clever tricks. But here's the big question: do these models keep getting smarter, or are we still stuck with machines that see data but not the world? Thanks for watching. If you want to see the wild equations the model generated, check the description. Stay curious, and we'll see you next time.